Okay, so the next topic that we are going to cover is tunnel survey. Okay, and in tunnel surveying, there are particularly 3 steps. So here we are going to understand how we set out tunnels. What do you mean by set out tunnels? We are trying to transfer the ceiling as well as the floor points of the tunnel inside the ground. So we all know what are tunnels. When you have to cut through a hill and when the depth of cutting goes more than 20 meters, okay, then you don't have open cuts. Okay, so if suppose there is a hill and you are trying to construct a road through the hill, so this is your hill. Okay, you can, let's say I want a road right over here. I can cut. There are 2 options. Either I can cut through this or I can have a tunnel inside this. So when do we go for this open cuts and when do we go for tunnels? When this depth goes more than 20 meters, then cutting is not feasible. Okay, it's too much of cutting. Okay, in which case you go for tunnels. Okay, and also when there is a lot of ground rising, okay, on the surface, when there is a lot of unevenness, then also we are not supposed to go for open cuts. When there is too much of unevenness on the surface, again what is more favorable is a tunnel. Okay, now in setting out of tunnels, there are particularly 3 steps. First is surface survey, next is transferring the alignment underground and transferring the levels underground. Now, what do we mean by that? See, now in plan, my road may look like this, like a normal road, okay, with this as a center line, okay. Now, my hill is like this. Now to transfer, first thing is I'll have to do the leveling of all these points on top of the surface. Yeah, all these points I need to do. I need to know the levels. Why? Because I need to know if, let's say this is my tunnel, my ceiling point or my floor point is how much below the surface line. Okay, so I need to do all the surface surveying. Then I need to transfer all these points down inside this tunnel. So how that is done? And after I have transferred this center line, okay, first I will set out the road on the surface, and when I'm trying to transfer the points underground, how those points are transferred here, meaning the levels, how do we transfer? Transferring from here to inside and then to get it exactly at the required levels. That will be my third step. Okay. Now preliminary survey or reconnaissance as we call it, the first surface survey, okay, will consist of around 3 to 4 kilometers on either side of the proposed alignment. So wherever your tunnel is starting or ending, you need to carry out a survey of at least 3 to 4 kilometers. Okay, and you need a plan which has contours drawn at the most at 5-meter intervals. So a second requirement is a plan or a map with a scale of 1:20 with contours drawn at 5-meter intervals. Okay, then you need also the details of entry and exit. Okay, where is this tunnel going to start and where is it going to end? Okay, we need to understand the facilities. What are the available infrastructure, the water supply or the electrical lines? Okay, we need to find out a detailed geological information. Where are the faults? Where are the folds? How much is the groundwater level? Because all these things will affect the cost of your tunnel construction. Also, you will study this probably in your transportation and the tunneling topic. Different types of geological strata are favorable and unfavorable for tunneling. So you need to understand what are the different layers, especially the ones which you are going to cut through. When you cut through are the layers of soil which are above going to remain stable. Okay, then the proposed route will be decided upon all these points under consideration. Alright, so continuing with the surface survey, which is the first step in setting out of a tunnel. Okay, as I already told you, first before the entry and after the exit, around 4 kilometers will be surveyed. Okay, and okay, for this particular survey, the scale that will be adopted will be very large, that is 1 in 20,000. So it's not a very accurate survey, but you need to have the information of all the geological or topographical data uh, before the tunnel starts and after the tunnel ends. Okay, the contouring will be done at 5 meter interval. What is a contour interval? Just to revise, contour interval is the vertical difference between the two contours. Okay, you all have learned contouring in survey 1. So if suppose this is my this is my hill, okay, and I'm trying to do contours of this hill, how will it look? It will look like this. Okay, concentric, with the inner part representing the higher elevation. So inner elevation will be 100, then it goes down, say 99 and 98. So that's how a contour will look. Over here now, what is the contour interval? 199. So your contour interval is 1 meter. Okay. So what they say is, when you're doing contouring, before you start aligning the tunnel, this contouring has to be nothing bigger than 5 meter. Anything less than 5 meter is okay, that is more accurate, but not more than 5 meter of contour intervals. Contour interval is vertical distance between the two successive contour lines. Okay, now final alignment is selected from this plan or surface survey, and it also includes various other data. Okay, proposed route will be decided upon the alignment of the center line of tunnel. Okay, gradient to be adopted. That is your tunnel going to be at a horizontal level, or is it going to be rising, or is it going to be falling? That also has to be decided. Now, on what will that depend? Whether your tunnel is going to be level, or is it going to be rising, or whether it is going to be falling. On what will it depend? So it will depend. See, this is my hill, and I have a tunnel to be constructed down. Okay, on what will the level of all these points depend? It will depend on which are the 2 points you are connecting. So your exit point and entry point, if they are at the same level, then you can have a level tunnel. But your exit point is at a lower level than your entry point, then it's going to be a falling gradient. Okay, so basically that's the reason always entry and exit is very important. Okay, then the width and the other dimensions of the tunnel will depend on the traffic that it is going to carry, or the cities that it is going to join. If they are going to be very highly metropolitan cities which are very crowded, then you will require bigger dimensions of the tunnel, maybe 4-lane tunnel. You are never going to construct a tunnel for a single lane or 2 lane, okay? Because there is no scope for widening a tunnel later. It involves a lot of cost. So you have to forecast the traffic which is going to come after, let's say, 5 years or 10 years down the line, and accordingly you are going to decide on the dimensions of the tunnel. Okay, then determination of exact length of the tunnel, that is also a part of surface survey. So when you do a survey all along this particular hill, and you know this and this is the point where it is going to start, and let's say where it is going to end, you also come to know what will be the length of the tunnel. Correct? Then you need some permanent benchmarks. So you will not get these benchmarks everywhere on the surface. So you have to create these temporary benchmarks. Okay. So wherever you get a benchmark, anyway, maybe before the entry or after the exit, using fly leveling, you are supposed to transfer it onto the surface. Why you need to transfer it on the surface? Because your surface is going to be the datum for while transferring the points down inside the tunnel. So I told you, the first step is surface alignment. After that, you transfer the points down. Now, how will I know which is my point on the tunnel if I don't know the point on the surface? So surface surveying, it has to be extremely accurate. It's like your datum. If this is accurately set, then only this will be set, because this is providing a datum for all these points. Okay, the ceiling and the floor of the tunnel. Okay. The instruments that will be used in setting out of tunnels are supposed to be very accurate. Nowadays, obviously, total station is used, but otherwise, if total station is not available, you will use a theodolite or a tachyometer whose least count has to be at least 20 seconds. Now, when I say at least 20 seconds, it can be 20 seconds or less, not more. Okay, it should be able to read very lesser values of angles. Okay, usually the ones which were adopted are 5 to 10 seconds of theodolite. But with the evolution now, as we are using total station, the least count of total station is 0.01 second is the least count, and accuracy is 2 mm. It's that accurate. What is the difference between these theodolites which are used in our normal surface survey and in tunnel survey? See, I told you if the tachymeter that you have used, okay, the telescope, okay, here there is a eyepiece and here there is a objective lens. Now this objective lens which you are using is probably 4.5 to 5 centimeter in diameter, right? The ones that will be used in tunnel survey will be around 4 to 9 centimeter. Now why such wide? Why so much of dia? The reason being, see, the image formed inside the telescope will be seen only when there is light entering inside the telescope. So the bigger the diameter of the aperture, more will be the light entering. A tunnel will obviously be a dark place. In some of the transits, in fact, there was earlier a hole which was provided, and here no, you would be actually using a torch to illuminate the image that is formed inside. Okay, that was also a provision. So for a tunnel transit, irrespective of what is the type of instrument you are using, the diameter of the aperture is kept larger, 4 to 9 centimeter. Okay. And then the other instruments that you require are usually tapes. Usually you go for 30-meter steel tape and a tripod. Okay, mostly aluminium ones. Okay, then surface alignment will include usually for short tunnels the driving is done only from one end. Okay, whereas for long tunnels driving will be done from both ends. Okay? It's very important that you set out the center line very accurately on the surface, okay, from end to end. Okay, and if the topography on the surface is very uneven, then the precision, I mean the instruments that you are going to use and the methods that you are going to adopt are going to be very, very precise. You will have to keep a check of all the points from at least 2 points. Okay, your triangulation or traversing has to be very precise. Okay, to set out the center line on the surface, a suitable point will be selected from both the extremities. Okay, here if that is especially for long tunnels, you are commanding from two ends. Okay, so you have to see that the point that you are selecting is very accurately marked. Okay, then there are observatories which are constructed. Observatories meaning mini stations, mini offices which will be constructed, okay, where you place your instrument. Okay, instrument centering, instrument leveling, these are at very high precision, not like the ones that we do in our practical examinations. Here, the leveling and centering will be extremely accurately done. Okay, we will continue